Hang on a minute. Okay. Okay, this problem. And let's just say we got 5/7 plus 6/3. And of course, B is bigger than A and B is bigger than C and C is bigger than B. So it wouldn't actually be this for anybody's actual numbers, but that's okay. It's going to be the same no matter what. This equals, you want denominator 21. We got to change 5/7 to a form that has 21 in the denominator, so we multiply this by 3/3. We have 6/3. And to get 21 in the denominator, we've got to multiply 3 by 7. And so, of course, we multiply by 7/7. This equals 15/21. That's 42/21. I can't be. Got it. 6/3 is 2. Depend that I didn't do that. Okay, so it works out. So we end up with 57/21. Okay. Now ordinarily I would have reduced this fraction 2/1, right? I wrote it down carelessly. Didn't think about what I was writing. Okay. But that's how you add fractions. Now that's, you got a whole assignment on that. If you didn't do the assignment, do it. Because you'll learn to do this. And you're going to need it. It's going to be important. Okay. B% of G, well, everybody got that. I'm not going to do it. Okay. And anybody that is, well, somebody watching might be. Okay. So let's take 6% is 6/100. Okay. Of course, we do that by fraction. 6/100 and 18/1. And that's going to be 108. Yeah. Over 100. Which is 1.08. There's a question, so many percent more than something else. I'm just going to use the numbers I had here just for convenience. Your numbers would have been different between this problem and this problem. So let's just do 6% more than 18 is 18 plus 6% of 18. Okay. You're adding the percentage to your original number, which equals 18 plus 1.08. Now writing it out, you want to write 18 plus 6/100 times 18. Okay. Make sense? That would be 19.08. Okay, so these should be just automatic, straightforward. Okay. I'm going to go over to these before I get into these. Now, 5 minus 7 plus 9 means -2 plus 9. I should do the 5 minus 7 first. Okay. Additions and subtractions are done in order. So we do and that's stuff. Okay. We can distinguish that from this. Now, seeing that negative sign, there's a temptation to put parentheses around. There are no parentheses. If there are parentheses, then you do what you might be inclined to do. But if there are no parentheses, you can't just put them in. Now, you could put parentheses around these because that's the first thing you do. Okay, first operation. 5 minus 7 plus 9 is that 5 minus 16, which is negative, negative 11. Okay. So you want to be careful about that order of operation. So that kind of covers what we're doing here. The difference between this and this is the parentheses. Okay. There are no parentheses. You do A minus B, and then you add C. Okay, well, let's look at the rest. The annual rate of interest on $100 for 8 months is if the interest is, if I use the word is there, is F. Okay. So there are various ways to reason this out. I can say that, okay, the interest for 8 months is $15. Okay. Well, we're looking for the rate. So $15 is $15 over $100. I'm going to change this from $100. $100 is a bad choice. Because you divide by 100 to do percents, right? So when I divide by $100, it looks like I'm just doing a percent, which I am, but not for the reason you. So I'm going to make that $200. Okay, that's 15 over $200, which is .075 of the $200. Okay. So your interest for the 8 months is 7.5%. Okay. Now you want the annual interest. Annual interest for 12 months. Now, if the interest for 8 months is 7.5%, there are 2 ways you can do this. Okay, 12 months is 12/8 of 8 months, right? Okay. Now, 12/8 is 3 halves. Divide the numerator and the denominator both by 4, right? Okay. So if we multiply this 12/8 by the 7.5%, excuse me, we're gonna get our annual raise. Twelve eighths for 7.5%. Okay. Okay. So let's see, 12 eighths, that's 7.5% equals, in the first place, let's just do 3/2 because we don't want to multiply bigger numbers. You write it like this, which is 22.5% over 2. We're just doing the arithmetic. Once we figure out we got to do 12/8 of 7.5%, we just write out that calculation, right? So the details of the calculation, well, you want to show all the details the way I'm doing it. Don't just write down an answer. If you screw something up and get the answer wrong, I have no idea what you're doing, right? Show me every step and show yourself every step so that you're thinking through every step and you're thinking as clearly as possible. Okay, well, anyhow, that equals then 11. 11.25%. That's one way to do it, okay? Now, another way to do it that word there, you can't read as months. 7.5% for 8 months is 1/8 of 7.5% per month. Or 7.5% over 8, which equals point, we'll put a 0.9375%. Okay. I didn't do all those calculations in my head. 8 goes into 75 9 times, right? With a remainder of 3, and 3/8 is 0.375. Okay. Just something you know if you learn to do arithmetic in the days before calculating computers. Okay. Something still kind of handy to know. Okay. Now, and I should say interest rate. I'm being a little careless, and we want to be real specific about what we're saying. Okay, the interest rate is 7.5% for 8 months, 1/8 for that or this per month, right? For 12 months, you multiply the interest per month by 12, right? If it's simple interest, it's compound interest. Well, we'll get to that later. You got to understand simple interest first. Compound interest is going to be very important, but we're doing simple interest. Okay, so for 12 months, your interest rate is I can't read that word rate, but it's 12 times your 1 month rate, right? And lo and behold, that multiplied out. Okay. 9 times 12, 0.9 times 12 would be 0.108, 10.8%. Then 3/8 of 12 is well, 0.04 and a half. And you have that 10.8 plus 0.045 is okay. So that's a couple of ways. And this is, getting into a little more complicated problem, right? It's not that complicated. You want to think about it until it becomes obvious. If you know how much interest you pay, you know what percent you pay, right? Now, if you know the period of that interest, how long you have that interest, if it's for 8 months, you're going to divide that percent by 8 and get the amount per month, okay? And then to get the annual amount, well, 12 months, multiply by 12 months, right? Or you can say that a year is 12/8 of 8 months. So you have 12/8 of this percent, right? And I wrote it 12/8 instead of 3 down. I didn't reduce it until we got down here because it might be 12/7, which you couldn't reduce. I want you to see the number of months here and the number of months here, right? Okay. So that's that. Now, the next one kind of gets us into something that we want to talk about today, which is writing equations. And we want to start really simple, because writing equations is not for the faint of heart. Okay? Now, so this problem, again, I think I said it on camera, just to be sure. And just go to the board for this one. We just move the camera. There we go. Okay. Again, we want to be able to translate this question into an equation. It's going to be an easy equation. We did this a little bit at the end of class last time. If you reviewed the class, then you're going to find it a little easier to understand this. Okay, as it's more just plug for, click through the class in 5 minutes. If there's something you don't remember, stop and watch it again, take notes, okay? Not requiring that, if you ever go to Khan Academy or whatever, okay, there are billions of internet resources. That's fine, you're not going to hurt my feelings. I want you to use whatever works. Okay, even if you do hurt my feelings, use whatever works. You're not going to hurt my feelings. Okay. So you have this statement, A% more than X, okay? So let's rephrase the statement. And let's say A is 8. And X is 8% more than $200. Okay, well, that's all right. That's not what it says. Okay, I'll use a mask for an excuse, kind of blocks what I'm seeing, but I think it's just being done. And I've got it wrong here because, well, let me actually do this. This isn't the problem. Let me do this just to make it. This is an easier equation to write. More straightforward, so just to get a little practice with writing equations. So I did something kind of stupid here. So I'm gonna follow up on it because it turns out it's not a bad idea to do this. And then we can do this. This is not this problem, okay? Can't read this because that R didn't come out at all, but it's a similar problem. X is 8% more than 200, but it's not the same. Then you could say that, well, $200 plus 800, so $200, right? And you can do that easily, that's 16. So that's X. So I write out again how I calculated X. And I don't even want to do that. I want to be really. Okay. So there it is. Okay, now the actual problem. And it's $200. Is 8% more than X. If you read the problem, it says, what is X? If 8% more than X is $200, right? So it says 8% more than X is $200. So we can just kind of rephrase that a little bit. $200 is 8% more than X. So now we have to write this as an equation. So what's 8% more than X? I'm going to actually give you a second and ask you to write down an expression for 8% more than X. You don't know what X is, so your expression is going to involve X, right? But what do you do to X to get 8% more than X? Okay, now, have everybody write this down. Nobody quite got it, but everybody did something pretty reasonable, okay? But here's what it is. First of all, it's X plus 8% of X, right? And you remember it's not one of the, well, this problem, 6% more than G, what did you do? You took C% of G and you added it to G, right? Well, you're going to take 8% of X and you're going to add it to X. Same thing you did with the numbers that I think everybody pretty much did right, okay? But now you're doing it with an X with a symbol, and that makes it a little more abstract. But if you think, what would I do? If I knew what X is, what would I do to get 8% more than X? I'd add X to 8% of X, right? So it's X plus 800 times X, right? I'll use that asterisk, it looks too much like an X. I'll use a dot because I think I've seen people doing that, okay? So that's 8% more than X. Let's be sure we understand that. 8% more than X is X plus 8% of X, which is this. Okay. Doesn't look like I got a big long fraction here, so put boxes around these. Now, what's the statement say? It says 200 is 8% more than X, right? So I'm going to ask you if you could write an equation down that represents the full statement. Maybe get that mask open.
Yes, sir.
Really need to keep them up. Thank you. Okay, so what I'm seeing is where it is. Okay, what it is mean. Okay, now I thought 30% of the class got it. Others are still thinking. Is means this is the same as this. Doesn't that mean that this is equal to this? Well, 200 is this means 200 is equal to this. So what we do is we get an expression for this. Here it is, 8% more than X. So now we can write $200 equals X plus 8 over 100 times X. Okay? So we've written an equation. Now we're not going to solve the equation because we're going to solve easier equations before we solve this one. This is not a particularly hard equation, but there are a couple steps involved. Okay, the next assignment is going to be one-step problems. Okay. Now there are other assignments. There's an assignment in geometry, circles and rectangles and parallelograms and stuff like that. And I've chosen not to say too much about that today. Let you work on it, and then we'll follow up and talk about it, because I think open math will get you through that pretty well. If I'm surprised, then we'll talk more about it. Okay. So anyhow, there's an equation. Okay, so well, it comes down now to the art of writing equations. Okay, so the equation we would write is X is how much you have left. How much do you have left? Well, you have what you started with minus what you spent, right? So this is what we got left, right? $2 minus B dollars. Or if you use your numbers, 16 minus 8 or whatever, okay? X is what we have left. So X would be G minus B. Now, if you forgot your numbers, that's the way you want to write it out. Because we just did those numbers, right? If you got your numbers, then you can put your numbers in here. If G's 18 and B is 7, then you could write out 18 minus 7, and X is 18 minus 7. Okay. Okay. Now, I'll give you a harder one. It's going to be that much harder. Okay. Actually, I don't want to write out how much you guys spend, that'll make you think of, give just an extra step of thinking, what you need to do, and it's pretty obvious. So I have F dollars. After lunch, I have A dollars. X is how much I spent. Write an equation expressing the situation. Okay, so there are several ways you can write this. And people wrote it in different ways. Okay, you can say, I guess I've got to go up here. Well, okay, you can say that your A X equals your F, because how much you spent plus how much you have is what you started with, right? Okay, makes perfectly good sense. Or you could say, it all depends on how you're looking at it. X equals F minus A, right? In other words, how much you started with minus how much you spent is how much you got. Okay. Or you could even say that you subtract how much you got from how much you started with, that's how much you spent, right? Every one of these equations makes perfect sense. And no one equation is any better than any of the others. So now we can rearrange each of these equations. If I subtract the A thing from both sides, I get this equation, right? Okay. I just subtract A from both sides. A goes away here and it appears over here as a negative, right? Or if I want to solve for A, I would subtract X from both sides. And that would give me this, right? Now, if I want to think about it first like this, then if I wanted to get X, well, I'd probably add X to both sides to get, and that would give me the same as this equation, wouldn't it? And then I could subtract A from both sides and I'd end up with this equation, and there's an equation that I've solved for X. Okay, so hopefully you understand a little what I said there. But again, we're not worried about writing the equations. Okay, if your equation is, if this is 5 plus X equals 18, you can solve that equation by subtracting 5 from both sides, right? Okay. And this equation would be X equals 18 minus 5. If A is 5 and F is 18, right? Here, you would have 5 equals 18 minus X. Every one of the equations represents the situation, and there's simple rules that we can use to move on from one equation to the other. All there is to it. You can always add the same thing to both sides, or subtract the same thing from both sides, or multiply both sides by the same thing, as long as you don't multiply by 0, which would wipe out all your information. Or you could divide both sides by the same quantity, as long as you don't divide by 0, which is forbidden anyway. Okay? So the assignment on equations, one-step equations, comes down to simple meanings, but the problems get a little more complicated. One more example, we got a few minutes, just a few. C percent of X is 2. And with your numbers, or if you want to do with the symbols, that's okay. Can you write that as an equation? Okay, we did pretty well with this one, okay? Now, this would be C percent of X is C over 100 multiplied by X, right? Because the odd means multiplied by, remember Coach 5? Okay. I remember Coach 5 when I actually is G, right? So is means equal. We translated it. Now, if the numbers are, let's say C is 7. EG means, for example, 7 over 100 times X equals 20. Okay, there's an equation. Now, I'm going to just tell you how to solve this equation real quickly, because we're actually over time it in one step. I can write 100 over 7 times 7 over 100 times X equals 100 over 7 times 20. Okay. 100 over 7 times 7 over 100 gives me 700 over 700, which is just 1, right? So this is just X. Now there's another step I'd like to write here, but I don't have room. Equals 20 times 100 is 2,000 over 7. Okay. And you can divide that out. Okay. It's going to be about $270. So there are simple rules for solving these equations. We'll be talking some about those too, but it's a one-step equation. All you have to do is multiply both sides by 100 over 7 and you get a solution. You don't have to use distributive law. You don't have to do a lot of rearranging. You can do it in one step. Okay. So the big thing is not solving one-step equations, it's being able to write them. And the big thing in mathematics is not just being able to solve an equation, but being able to write one that means something. It gives you a solution to something you need a solution to. Okay?